I hope you're ready for this. Today's the day that we learn both types of special right triangles. So we did look at this 45-45-90 triangle. It's the isosceles right triangle. And we discovered that those two congruent sides, it turns out that that hypotenuse is always that length times the square root of 2, which is no big deal when it's just a whole number. But then it gets a little confusing when there's awkward numbers on the legs. But again, we just take the length of that side times always the square root of 2. And in this case, we'd get 2 square roots of 12. We'd want to simplest radical form that. I can do the square root of 4, but the square root of 3 is irrational. So 4 square root of 3 would be the hypotenuse on that one. And then, do you remember, so we multiply by the square root of 2, and we get a longer length that represents the hypotenuse. So how do you make a smaller length? You divide by the square root of 2. So 4 square root of 5 is awkward, and we're going to divide that by the square root of 2. But remember, we can't leave our answer like that. I mean, technically, that is the right length, but there's this rule that you can't leave a radical in the denominator. So to fix that, we multiply by this fancy number 1, square root of 2 over the square root of 2. And on the top we get 4 square root of 10. On the bottom we get the square root of 2 times the square root of 2, which is the square root of 4. And the square root of 4 is 2. And you can't reduce the 10 over 2, but you can reduce the 4 over 2. So that would be 2 over 1, or 2 square roots of 10. Which, if you typed it in and got the decimal, which we don't need to do because we want to leave our answers like that, that will be a slightly shorter length than that hypotenuse was, because we divided by the square root of 2. And so that was the rule on all of these, that in order to go from the leg to the hypotenuse, we multiplied by the square root of 2. And to go from the hypotenuse to the leg, we divided by the square root of 2. And that's just something that you'll have to memorize, that square root of 2 relationship. There's different ways to think about it. We could sort of use this algebra way. We could use similar triangles, but no matter what, you have to memorize that square root of 2, and no more Pythagorean theorem for this type of triangle. That brings us to the next type of triangle, the 30-60-90 triangle. And I started this one by showing you, I just am giving it away, that the shorter leg, see how the legs aren't congruent this time, but the shorter leg and the hypotenuse, you always see that doubling relationship. So if we tried the Pythagorean theorem, remembering to put the hypotenuse in the c squared part, what are we going to get? We could do this for any number of different 30, 60, 90 right triangles, and we should see a pattern starting to come. Square root of 75 is that 3 times 5 times 5. So the 5 times 5 can do the square root. So the square root of 25 is 5, and the square root of 3, we're going to leave it, and obviously it's the positive version of that, so 5 square root of 3. So I wonder, do you know what the pattern is just by seeing the first one? I gave it away that there was a pattern. Here we are on the short leg. You'll notice that it's across from the smallest angle, and the hypotenuse is across from the biggest angle. And then there's this medium side leg. I'm going to call this the long leg, and it's always that short leg times the square root of 3. And that's the pattern, that's the relationship that we're going to have to remember for 30, 60, 90 degree triangles. So let's just practice a few. I think the easiest type is when we're given this shortest leg length. So this one says that the shortest leg is 4. Do you remember which one is which? Which one is double? Which one is 8? And the answer is it's the hypotenuse. It turns out that multiplying by 2 makes a bigger number than multiplying by the square root of 3. Do you know why that might be? The square root of 3 is only like 1.7. So if you want the biggest number possible, we're going to take it times 2 to get that hypotenuse. That's always how I've remembered it. So here I am, I've got the small side. To get the hypotenuse, I'm going to double it, times 2. I'm just going to leave it 2 times the square root of 7. And then to get this longer leg, I'm going to take that times the square root of 3. And that would be the square root of 21. And actually that's already in simplest radical form, so I'd be done. So this time there's kind of 2 things that you have to remember, right? There's that twice as long, and there's that square root of 3 times as long. Again, this is another one that you'll have to memorize, just like the square root of 2 for 45, 45, 90. You have to memorize this relationship for the 30, 60, 90. This one's just a little tougher because I didn't give you that amazing short leg that I like to have. But I gave you the hypotenuse. Do we know the relationship? Now this isn't 30 degrees, this is like 30 inches or something. Do you know how long this, I call it the short leg is? Did you say 15? Because if you know that this is the doubling relationship, right? If I knew this one, I would double it. So if I know this one, I will divide by 2. And once I know that this is a 15, then I can get that long leg just by swinging around here and taking 15 times the square root of 3. Not too bad. So if I know the hypotenuse, I never want to go to the long leg first. That's why I put that star on the short leg. I always want to know what that short leg is if I can. Now, do you guys know what the square root of 10 divided by 2 is? Because it's not the square root of 5. We're actually just going to have to leave it like that. It's 1/2 of a square root of 10. And it's okay to write that like that because there's no radical on the bottom. Now, once we have this short leg, we're just going to take that times, what is it? The square root of 3. And that's square root of 3 over 1 technically. So this would be the square root of 30 over 2 times 1 is 2. So I took this times the square root of 3 and I got the square root of 30. Again, that one doesn't reduce. We should probably check with a factor tree, but the square root of 30 we can't. That's already in simplest radical form. One more of those. If I give you the hypotenuse, which one do you want to find first? Always the short leg. And what am I going to do? If I want to make a smaller number, I should divide by 2, yeah? Divide that by 2 and we get 4 square roots of 3. That's what half of 8 square root of 3 is. And then once we know what that is, we're going to take that and multiply by that square root of 3. 4 times the square root of 3 times another square root of 3, which is kind of crazy. So 4 square root of 9. Can you do the square root of 9? So that side is just 12 inches long or something. So all of these represent actual numbers. We just don't have them in decimal form, and still the hypotenuse is the longest, the short leg is the shortest, and the 12 would be right in between those two. The last scenario is kind of the toughest one, I think. So if they give you the long leg, again, we don't want to go to that hypotenuse. If we can figure out that short side, we're going to be good. And remember, in order to get from the short side to the long leg, we multiplied by the square root of 3. So let's divide by the square root of 3 to go backwards. So 15 root 3 divided by the square root of 3 is 15. And if that's 15, you know how long the hypotenuse is? It's twice as big. Oh, I think we just did one like this. So if we take 12 divided by, what are we dividing by? Because I want it to get smaller, so I'm definitely dividing, and the magic number is the square root of 3. I can't leave my answer like that, but it's technically correct. I'm going to do that little move. It's called rationalizing the denominator. And I get 12 square root of 3, multiplying straight across, 12 square root of 3 over the square root of 9, which is 3. And the 12 over 3 reduces to 4, so that was 4 square root of 3. Double that, 8 square root of 3. This is that same example, isn't it? Alright, last one. Awkward number. Don't care what's there. I know I'm going to go to that short leg and I'm going to divide by the square root of 3. 4 square root of 2 divided by the square root of 3 is some crazy number, but I can't leave my answer like that. I'd give you half credit if you left your answer like that. At least you knew to divide by the square root of 3. But now we're going to multiply straight across. We're going to put it in mathematically acceptable form. Square root of 9 on the bottom. The square root of 9 is 3. And now I'm happy with that. You're probably thinking that doesn't look a lot better, but I'm happier with that because there's no radical on the bottom. Doubling that, again multiplying by 2, would be 8 times 2 over 1, so 8 square root of 6 over 3. Can't reduce the 6 over 3 because the 6 is in the radical. 8 over 3 doesn't reduce at all, so we're done. So just a quick review, how does this work? Remember, on a 45, 45, 90, we always have matchy-matchy legs because it's isosceles. And then if we wanted to find out the hypotenuse, we'd multiply by, what's the magic number on this one? The square root of 2. So this would be whatever that number is times the square root of 2. On a 30, 60, 90, I much prefer to have this short leg figured out because once I know that, I can multiply to get these two longer the longer leg and the hypotenuse, multiply by 2 to get the biggest guy, and multiply by the square root of 3 to get the medium one. And if you find yourself needing to go backwards, then you just divide by the square root of 3 or divide by 2.